Broadcast is now starting. All attendees are in listen-only mode.
Okay, good morning, good afternoon, or good evening, everyone. Thank you for joining us today. Today's webinar is about a better way to design bridges. And we're going to kickstart the webinar, but first I would like to start with few poll questions that I would like you to answer in order for me to understand what is the audience like, what is your background, what type of tools do you use usually. So let's start with some polls. Okay, so the first one, we would like to know where are you currently based? Is it the Middle East, Africa, Europe, the Americas, Asia, and others? Okay. So apparently we have most of the audience today coming from Africa. Okay, great to see that. About 22% from the Middle East and another 22% from Europe. Okay, perfect. So I'm going to show the second poll question now. And the question, how often do you use Infraworks in your projects? Is it like you use it on a daily basis, weekly, maybe once or twice per week, monthly, rarely, or never ever you have opened or used the software in your projects? Okay, so most of the audience today, we have around 30% rarely using the software and over 57% never using the software. Only 14% use the software on daily basis. Okay. The third poll question. What is your current role within your organization? Are you a design engineer, whether civil, bridges, traffic, anything? Are you a contractor, an Autodesk partner, an Autodesk employee, or some other role? Okay. So we're gonna give few more seconds. The answers are still coming. Okay. So as expected, we have a third of the audience as design engineers, the other third as Autodesk partners. We have very few Autodesk employees online and around 20% other roles. Perfect, thank you very much. The second question that we have for today is what tool or tools do you mostly use for bridge modeling or design? Do you use Infraworks and or Revit or basically any of the Autodesk software? Do you use Bentley solutions like OpenBridge, Modeler, Leap, and others from Bentley? Or else maybe CSI solutions like CSI Bridge, SAP 2000, etc. Maybe a mix of the above or none of the above. Okay, so the answers are still coming. Okay, perfect. So we have around 55% using Autodesk software like Infraworks and Revit, and the other 45% using none of the above solutions. Okay, thank you. So now we're gonna kickstart the webinar. Okay, before I start with the agenda and the topics for today, I would like to introduce myself for those of you who have never attended any of my previous webinars. My name is Muhammad Abu Asali, and I am based in Dubai, United Arab Emirates. I am an Autodesk AEC technical specialist with a focus on infrastructure. My territory is covering Middle East and Africa. I'm responsible for infrastructure workflows and solutions involving ones like Civil 3D, vehicle tracking, the geotechnical module, Infraworks, Navisworks, 3ds Max, and construction cloud solutions like BIM 360. I'm a civil engineer by degree, a graduate of the American University in Beirut 2008. I am PMP certified with diploma in supply chain management and a master's degree in neuro-linguistic programming. So far, I have 11 years of AEC industry experience, out of which 5 years are with Autodesk. You can basically connect with me using LinkedIn or subscribing to my YouTube channel, where I'll be posting all of these webinars, the recordings of these webinars online for you to check later on. Okay, so what about today's agenda? This webinar is basically about the recommended Autodesk bridge design workflow that basically involves four major solutions. We're talking about Infraworks, Inventor, Autodesk Civil 3D, and definitely Revit. Now, we're going to touch upon all of these listed topics throughout the presentation. Okay, so I'm not going to talk about them. We're going to see them one by one. First, since like over a 45% of you never use the Autodesk software or they're not using Infraworks and their bridge design workflows, I would like to just briefly introduce Infraworks to you guys. Infraworks is a very environmental friendly or very user friendly software that basically helps us in the planning up till the detailed design of the project. So it's basically concerned with the preliminary and conceptual designs of infrastructure projects. Excuse me for this, it's Infraworks without the 360. The software used to be called Infraworks 360 before, not anymore since last year. So it's just called Infraworks and not Infraworks 360. So it basically helps us with the creation of the 3D models, the visualization, the analysis of the performance of those models that we create, the evaluation of material takeoffs, and in some instances, the cost involved, as well as communicating that 3D design to stakeholders and anyone interested in the project. To the right-hand side, you see a very easy user interface, as you can see, with drop-down menus. And within the software, we have three major modules. There's one for road design, another for bridges, which we're going to use heavily today, and another one for drainage module. Infraworks, as engineers or planners, helps us in the planning and designing within context, meaning I do have the power and the capability to get huge areas around my area of interest and basically design within that area. I'm able to better visualize and explore different alternatives, as we'll see in a couple of minutes with bridges. We're able to design and check the performance and cost evaluation, and basically move that design, whatever we create in terms of infrastructure objects, into detailed design and tools like Civil 3D or Revit or others. Infraworks is very powerful because of its interoperability capabilities. So this diagram basically highlights how Infraworks kind of sits at the center of most of the workflows. So we're going to use Infraworks for the preliminary design. We'll see later on in bridges and roads. How do we visualize those roads and bridges, analyze them, simulate them, and get quantities? It has a bi-directional link with AutoCAD or Autodesk Civil 3D, where we do the detailed design, we can do swept path analysis, detailed quantities, and documentation. At the same time, we do push some structural objects like bridges and tunnels directly to Revit for further detailing later on. Infraworks also connects with 3ds Max and 3ds Max Interactive if we want to go one step further into augmented reality or virtual reality environments. It also reads parametric models created in Inventor. So this is like a one-way read of data, but we can't push back to Inventor. And we can push back and forth using FBX file format into Navisworks for things like project review, 4D, 5D simulation, and clash detection. At the very top, we have this capability of moving data from Civil 3D to Revit using either DWG or exporting an AEC file, or even using the BIM 360 platform to publish a Civil 3D terrain for usage inside of Revit. So why Infraworks is so important for bridge design? Infraworks is contextual, parametric, and dynamic, meaning it's contextual because we have the context. We have everything that you can think of, from terrain to utilities, roads, buildings, etc. It's parametric because every object within Infraworks, whether it's a bridge component or a road or a grading, we can basically change the shape or the parameters of that object by just inputting some figures in there, and everything in terms of 3D will update. It's dynamic because objects are intelligent. We're talking about a BIM platform here. So if I move the bridge or I elevate the bridge, the whole profile of the bridge along with the connecting roads will update automatically. So we're gonna use it for the proposals. We're gonna use some of the built-in design standards. We're gonna do some analysis, structure analysis for bridges. We're gonna generate some of the quantities, use it for visualization and design communication, and then move to Revit for detailing and documentation. And maybe if need be, we can push all that together into Navisworks for construction staging, reviewing, etc. So if we want to go in detail into this workflow that we will cover during this webinar, you see that we start from Infraworks. So this is the starting point. We use the bridge design module with its default components, BIM components, and then we can have also customized components, because in each and every country, we do have specialized components. So we can create those components and use them in Infraworks by leveraging Autodesk Inventor. We create those, we import them into Infraworks, and then we model our bridge. Now, once we're done from modeling our bridge or different alternatives and doing the structural analysis, we can push that bridge directly into Revit. So this is the link that you see at the top. This would be maybe the second step. We push the bridge to Revit, and then we have a 3D representation of the whole bridge in Revit, in the Revit environment. Also, we can push the whole Infraworks model into Civil 3D. There is a bidirectional link, as we mentioned earlier. So we see the terrain, which maybe was generated in Infraworks from a point cloud. We see the roads, and even we see also a 3D representation of a bridge inside of Civil 3D. We can push into Navisworks using FBX, and if we need to push more data into Revit to have the context while doing the detailed design, there are several ways. We can either push a DWG into Revit, but this is dotted line. We can push an NWC, NWD as a link or reference for the Revit model, also as a dotted line, because these are not the best workflows to do that process, because Revit at the end of the day does not understand contours, it understands points. So there will be some misinterpretation of the terrain. The best way to do it currently, and the recommended one by Autodesk, is that we push the Civil 3D terrain model using the BIM 360 platform. We publish it to BIM 360, and then we can use it inside of our Revit platform. So now we have the context inside of Revit of the terrain, of the maybe utilities required or anything else. And then we have the bridge model coming from Infraworks, and then we go into the detailed design part where we basically change maybe the shapes or types of material of the components, and then we add the structural rebars or reinforcement, and then we generate the construction documentation. This is what we're going to go through in today's webinar. So in Infraworks, since we mentioned that we're designing in context, for those of you who are new to Infraworks, there's a very powerful feature that basically allows us to create free 3D models of a city scale up to 200 square kilometers for free. What you're seeing on the screen is Model Builder. So we're basically typing in a city of interest or any place on Earth, and then we're searching for that place. Then we pick an area of interest up to 200 square kilometers. We type the name of the group, and then we share it with one of our design members or design groups, basically, so that other team members can have access to this model that's basically residing in the cloud. Now, once it's created in the cloud, we were able to download it and have it on premise. So once we download that model, we're going to have the full model residing on our laptops or internal servers. There's no need anymore to connect to the cloud for checking the model. What we're going to end up with is something like what you see on the screen. This is for the city of Cape Town, the capital of South Africa. And inside that model, you will have different data sets or data sources. We will have the terrain coming from different sources. You will have the roads, the buildings, some bridges coming from OpenStreetMap. You will have the raster data coming from Bing Maps and others as well. All of this is properly georeferenced and to scale. This is just as a starting point to start the design process within context. But we already know as designers that we need to have the latest update in terms of terrain, existing utilities, and so on and so forth. So how do we do that? Well, it's recommended that we start with Model Builder, and then we augment our model by importing whatever data sources, accurate data sources we have in many different file formats. Infraworks is very intelligent to bring those data in and overlay them on top of each other to end up by having the augmented BIM model for the whole area or the whole city that we're designing in. We're also capable of linking those BIM objects or 3D objects with databases, whether it's from Oracle, MySQL, WFS, and any generic database like the ones coming from Esri, a GIS or a geodatabase. Just to give you an example of how things work in Infraworks. So basically, the terrain that we're going to get from Model Builder is not 100% accurate. And this is mostly the case, right? So this is what we will see inside of Model Builder. A little bit of triangulation here and there, but basically not much. What we are supposed to do is bring in the point cloud data, extract the surface from it, or else if we have a surface that's residing in Civil 3D, maybe generated in Civil from surveying points, then we can bring that data in and then, you know, update or upgrade the existing surface with the most accurate surface that we have from surveying. Then we can kickstart the design process inside of Infraworks. Instead of showing you so many videos and slides, I decided today to do some, you know, a live demo for you. So I'm gonna move quickly into the software and show you that Infraworks is very easy to use, specifically when it comes to bridge design. So this is the home page of Infraworks. Once you open the software, I'm gonna just click one of the models in here, and as you can see, we can support huge models that are basically hundreds of gigabytes. This is the scale, what we're talking about, that comes from Model Builder. It's 200 square kilometers. And as you can see, I do have, for instance, the towers in the marina area, the JBR even, and the JLT. I can have also the whole of the Palm or any area within Dubai or any city on Earth. Now, the cool thing about Infraworks is that this model basically resides exactly where it's supposed to be on Earth. Meaning, if I zoom out from this model, you will directly see that this model is properly located in Dubai in the United Arab Emirates. So I'm having the right coordinates, the right XYZ details. If I go further, I'll be able to see from the model properties that I can basically assign any coordinate system to my model, because we need to have our models properly georeferenced. If I'm working, let's suppose, in any other country, let's say in South Africa, because we have so many people from Africa today. So Republic of South Africa, let's see. So as you can see, we have all of the coordinate systems in South Africa already available in here. And these are basically generated or taken from the library that's available in Civil 3D. So Infraworks and Civil 3D share the same coordinate system library. Once I pick one, everything will be translated to that coordinate system. I can definitely pick, for example, the model time. I can pick the design standard if I have any design standard in here that I would like to design upon. I can specify whether I'm driving to the left-hand side, right-hand side in the model. And as you can see, once I move throughout the model at any point, I do have the XYZ coordinates in there. So this is enough about Infraworks. Let's start by going into some, you know, free area where we can basically experiment with the bridge and road design modules. I'm going to start by picking the road module and then going into component roads. There are many ways, a couple of ways of how to design a road. And then here we have so many different cross sections or assemblies, as we know them inside of Civil. All what I have to do in here is just pick one assembly, and then I can start basically the design process of my road. As you can see, I have the curvature in green. If I violate the design standard, which is in this case AASHTO metric 2011, I'm going to have a warning signal at the very bottom. So I'm designing in context as per a certain design standard. Whenever you click a single click on the model, once sketching the road, you will create, or you will basically generate a PVI, a points of vertical intersection, and all of the necessary or required labels will show up automatically. If I look in profile versus plan, so these labels will update. Okay, fine. I'm gonna go to this point in here, and then what I'm gonna do very quickly is basically, let me show you that this is actually a 3D created road from the assembly, as you can see, with all of the required components. Okay, I'm gonna go to this PVI in here and very simply just pick the PVI. Once I click on the PVI, I'm able to lift that PVI or change its rotation. So here I've picked it in plan, so things were different. I want to pick it as a profile. Okay, so here I'm gonna lift it up. Okay, it's updating the, okay. The other way of doing it is basically going to the profile view. So here I'm gonna show you the better way of modifying the design. As you can see from the profile view, and this is what we need as designers, we have here the elevation, we have the exaggeration scale, we have here the chainage or the station, 250, 500, etc. And we have direct feedback about the road design that we've created in terms of slopes, points of PVIs, etc., etc. I'm going to create more PVIs in here just to be able to influence my design a little bit further. Then once I move into the model, I will see that the model has been updated with those PVIs. So now I can either click on that PVI and change the elevation from here, or I can change it from the profile viewer, or just lift it up the way that I like. Let me just put 25 meters. Once I hit enter, you will see that the model has been updated in the profile and the 3D model has been updated in my canvas. Okay, so we can basically modify the rest of the road, as you see here, and then just to make the profile sound a little bit or look like a proper road, proper curvature, and modify it a little bit. Now I'm gonna pick the bridge design module, go into the designing structures, and here we have 3 different options. We can either design a concrete precast girder bridge, a steel plate girder bridge, or even generate a tunnel underneath the ground or underneath a water body. For this instance, I'm gonna pick this concrete bridge, and I'm gonna pick the station, as you can see, either by rolling this carpet from the station, starting station to the end one, or just typing the station as I like. So I'm gonna pick to 170, and I'm gonna move all the way till, for instance, this place. Once I hit double click, the software automatically will read all the information, will assume a certain dead and live load, will basically check the design standard for the bridge that I've selected, and will generate a 3D sound bridge for me with all of its required components. So here, I want to bring to your attention the following. As you can see, we do have the piers. If I zoom in a little bit, you will find also the bearings in between. We have the girders, the concrete girders, which we can change one by one. And I also have the deck, the bridge deck. And if I go to the side of the bridge, I move inwards a little bit, you will be able to see that we also have the bridge abutments as well. Now, if I go underneath the ground, I'll be able to see the piles and their foundations, or the pile caps, and definitely any existing utilities. So if anything is existing, we can check it from there. Now, if we have a bridge, there are 3 ways of selecting components. Either we select the girder, so if we pick here, we select the girder, and then everything will pop up regarding that girder. Then we can select an assembly, for instance, and we can change the whole assembly. We can pick here the deck instead of the girders, and same story. So we can pick, we have only here one basic component, but we can create ones in Inventor and bring them in. Or else, if we click on the top of the bridge, we're going to select the road style. So here, we're not talking about bridges, we're talking about the road style. So what I'm going to do is basically select the bridge, and then from here, I can change from concrete to steel plate very quickly, or else I can change the design standard that I'm working with. For this case, I'm going to stay with the AASHTO. What if I want to have a less number of piers? Or what if, for example, as per the design, or as per the plan, the master plan, I need to have another road underneath that bridge. So what I will do is actually tell the software I don't need an intersection at this flyover. This is undergrade. And as you can see, we can now understand how things will look like in 3D. Definitely these pipelines should be downwards. So I have a couple of options. I can pick each and every component and move it sideways, change its station basically, or even rotate it if need be. Or else, if I pick the bridge as a whole, I can basically change the bridge in terms of number of piers. So I want to have, instead of 4, I want to have 2. And this is when we talk about parametric design. Everything is changing within context. Okay, so now we have 2 piers. We can basically have the pier exactly rotated along this median, or else just make sure that it's moved to the side. If I change any of these parameters to the side, everything will update in 3D. As you can see, we have the materials, we have a texture, we have type of concrete, we have the cap parameters, the columns. I can change their spacing, the number of columns, the diameter, and even their shapes if I want them to be the lifespan, etc., etc. So I'm not going to waste your time on this. You can experiment with it later on. But the cool thing about that is that once I'm done from creating the model, I can easily for example, save another alternative. So bridge 2, and the original one was saved. Now any modifications I make to the second one will be saved along the second bridge. Fine. What we can also do is basically click on the bridge, and once we do a right click, we have direct feedback about the quantities. So all the concrete quantities will be calculated for me in terms of structure and substructure. What if I change the type of the bridge and I take a steel plate bridge? So I have another proposal. This is proposal 2. Now I have, as you can see, steel girders. If I click on the bridge, right click, quantities, I'll have both the concrete and the structural steel required for the steel girders, but not for the reinforcement. Okay, all calculated for me automatically. If I hit also right click at the bridge, I can apply so many things, or else I can send the bridge to Revit automatically for detailed design, which we're gonna see later. Okay. Okay, what else we can do with the bridge? We can basically specify something that we call the clearance envelope. So as designers, we need to have, as per the plan, maybe a certain clearance envelope of 20 meters. So we see that this envelope is basically not satisfied with the current bridge design. All what we need to do as designers is basically right click on the design and ask the software to automatically update the profile as per the required clearance envelope. And you will see automatically what's going to happen in a couple of seconds. The whole profile of the bridge, along with the inward and outward roads, have been updated to accommodate for this clearance. Again, we're working with BIM components. Now, if we want to go one step further, we can basically use the analysis tools in here. So we can go for line girder analysis for the structural detailing, which I'll cover later. We can do some flood simulation. And definitely, if we want to go for traffic simulation and mobility simulation, we can use those capabilities to check if the number of lanes of this bridge will accommodate the required traffic or the current traffic now, or the traffic forecasted for the coming 10, 20, or 30 years. So everything that you need to do is actually available in there. Okay, I'll go back to the presentation. We're done with the live demo. And let's start with, so we've covered this part. What's really important is that all of these components can be modified individually or as groups. So you can change definitely the style of the road on top of the bridge. You can create different zones. For example, you can check also the cross section along that bridge. So some of the analysis tools within Infraworks, built-in analysis tools, you pick a certain girder, you can select what objects or what structural objects you would like to see, so that you will be able to see some of them and not others, simplifying the analysis and visualization process. Also, you can basically change the cross-section of these girders of the bridge from one station to the other. So by clicking on the plus icon, we create a station or a zone, and then you will see that we're able to influence how these girders look like in terms of size, depth, thickness, etc., etc. We covered this. We covered the bridge material takeoffs. We covered the components. We covered, okay, you can actually change the piers and all of the components in Infraworks simply by picking from the existing library for existing components. As you can see, you can apply it to 1, 2, or even all the piles or piers in your model very quickly. You can actually also save that bridge with all of its components as per the latest design as a template, so that you can use it later and apply it to any upcoming design project, saving you a lot of time and effort in the process. And definitely you can send the bridge to Revit, which we're going to discuss later on. We covered the bridge clearance envelope. Okay, Infraworks is a very powerful platform to bring in huge data sources. So for instance, I can scan an existing bridge if I have some rehabilitation or some works that require widening of the bridge, adding some lanes. And then I can bring that data into Infraworks in order to understand what's the scale, what's the existing width, and see if there are enough clearance between the existing bridge and maybe other infrastructure objects like a rail track, a nearby building, etc., or a certain landmark. So it helps me in the design process and analysis. I can also bring into Infraworks raster data, like from basically any file format. I can bring that in and superimpose it as a terrain overlay. This is the way that we configure it. Or else I can basically drape an AutoCAD 2D file into my design in order to replicate the existing conditions of a certain bridge, or even start the design process based on that plan view. And then inside of Infraworks, as we've seen earlier, we can change the starting point, the end point, the number of girder, the size of the columns, the number of columns, etc., until I get those columns as per the master plan or the plan view drawing that I have in mind. So we've done the basic design, the conceptual preliminary design in Infraworks. We got an idea about the quantities. What about customizing that bridge design? So the process or workflow that currently exists is basically by leveraging Autodesk Inventor. Autodesk Inventor is a very powerful tool to create parametric objects. It's used heavily in the manufacturing workflows, but we can basically use it in our bridge design workflow. So we create those components inside of Inventor. We save them as an IPT, basically Inventor part. And then that IPT file will be imported into Infraworks and configured properly so that we can use it in our bridge design. So we replace, let's say, a basic component from within the Infraworks library with a new customized created parametric model from Inventor. This is how things work. So we have the style palette inside of Infraworks, and if you go to the parametric models tab in here, you will see that we have certain categories for all types of objects for our bridges, from girders, piers, abutments, decks, etc., Now, we can actually open an existing component in Inventor and just modify it and save it back as a new component, or else we can start from scratch. So what we're doing here is basically sketching a custom component, whether it's a pier, a foundation, pile, or anything. We're maybe like creating some voids in the component. We can assign material. We can do certain functionalities like lofting, for instance. And then we save it using the infrastructure part shape utilities tab. Once we're done, we can test it and check that it will work properly. So we have all the labels available for us to change inside of Infraworks, the parametric labels. Once we export that file, we save it as an IPT, then we're ready to import it into the Infraworks library. Back again into the style palette, we go into the parametric models, we drag and drop or import that model. We just configure what is that type of part that I'm bringing in, and then we specify the part size, the name, the label, how would the label look like in the asset card of the Infraworks, and then which ones will be visible, which ones will be editable for me as a designer. Now we have those available for me to be used. As you can see, they're populated inside the component library. And all what we need to do if we pick a certain component is select that component and then either assign it to a group or even assign it to all girders or all piers within my model. And as you see, the change is automatically happening in 3D, which will definitely have an impact on the quantities and then the detailed design, which is pushed into Revit. The second example is basically by, for example, creating cornices. So we can also create these parts inside of Inventor, as you can see here, save them as an IPT file, and then bring them into Infraworks to be placed properly along the sides of the bridge. Once we import that cornice or any 3D object, it might not come exactly in its right location, that's normal, but we are able to modify that location, rotation, tilting, etc. by modifying the parameters that come with the component in the asset card. So this is the parametric design of those components. Once we modify all these, you will see that this component will be rotated properly and then will fit in its right location, which also will have an impact on the quantities as well. A third example will be regarding city furniture or bridge furniture or decorations. So we can create, for instance, the street lighting poles, we can create the guardrails in Inventor, save them as parametric objects and bring them into Infraworks to do the same thing like we've done before for the girders or the cornices. The fourth example will be to edit or modify the component, the road components for roads approaching the bridge, or basically coming in and out of the bridge. So here we're changing, for example, the sidewalk, we're changing the guardrail, we're changing maybe the lane width, etc., etc. All of that is possible inside of Infraworks, and this is basically some very basic functionality inside of Infraworks for road design. Now, some of you might ask, well, I don't know Inventor, I would like to learn it. If you want to learn Inventor the easiest way, I highly recommend that you check this video for my colleague Andy Manzi. It's called Infraworks Custom Bridge Components, and it's available on YouTube. So my colleague walks you through the steps on how to basically open Inventor, how to start sketching these parametric objects, what functionalities you can use, like lofting, like having voids, and how to save that component and bring it back into the Infraworks platform. It's a very quick workflow that takes you less than 20 minutes, as you can see over there. All what you have to do to get into that video is basically go into YouTube and just type, as I told you, Infraworks Custom Bridge Components. The second one that will show up, Infraworks components from Andrew, will be available for you to view and learn from. Okay, so it's not actually a very tedious process. It's basically very simple, and you can teach it to others in a matter of 20 minutes. So now we're done with the final design, let's say, of the model in Infraworks. We've changed the profile, the cross sections, the components. What about moving forward into structural bridge analysis? The workflow currently is as follows. So we're using Infraworks to push basically the model of the bridge into the cloud. This is the only option we have right now. We push it into the cloud, into the Autodesk Structural Bridge Design cloud engine, where the line girder analysis will happen. Once the analysis is done, we're gonna have the results pushed back into the Infraworks platform, where we'll have like a couple of parameters or figures about how the bridge is performing, and some kind of coloring or thematic coloring for the bridge girders. Now, once we're happy with the design, we finalize the design, we're happy with the analysis, we can basically download the full structural report, which is over like 50 pages, detailing exactly how the bridge is performing, like showing you the shear, the moments, the bending moments, etc., etc. And definitely you're able to also download the local file that can be then used for the final modification and tuning of the analysis inside of the on-premise structural bridge design software. Okay, so this is how things will work. We have a bridge, and then we go into the line girder analysis. We send this model to the cloud. Once the analysis is complete, we're going to have a representation or the notification there. If everything is in green, means everything is okay. Nothing is basically, nothing requires modification. We can basically get the report. Once we hit on the report button, get full report, we have the full report, which is, as I told you, it's usually a detailed report with all of the structural calculations. And then at this point, we will be basically charged cloud credits. So you can run as many simulations or as many analyses as you like without consuming any cloud credits. It's only when you get the report and download that local file that you will be charged cloud credits for this simulation or analysis. And as you can see, based on just the basic parameters or results that we get from the software, the free of charge, we are able to tell if we need to change maybe a girder, the size of the girder. In this case, maybe it was too strong. We can pick from the proposal another bridge with another type of girder and then proceed with the detailed design. So you can run as many iterations as you like. Then if you pick, let's say, one single iteration as the one right for the detailed design, then you can get the full report and move on with the design process. So here we're downloading, open in Autodesk Structural Bridge Design, we're downloading the local file to our local machines and then automatically opening it in the Structural Bridge Design software. Here we're able to do so many basically modifications. We can verify that the structural strength of bridge girders is verified. We can get the results on screen. We actually, for this example, we will have the live loads and dead loads modified or added as per the requirements. We can also once done with the analysis, push these results to the individual beams and show the results in many different ways. And definitely check for things like deflection, for instance, and optimize the tendons that are available for that bridge. All of that happens inside of the structural bridge design software that's basically installed on your machine. So you get all these types of analyses. As you can see here, we can specify a certain fatigue model. We can specify a certain live load, in this case, a military vehicle of certain specifications. And we have the capability to optimize the tendons inside the bridge. Now, some of you might ask, well, this is a new software and I would like to learn it. The best way to learn it is by checking the Autodesk Knowledge Network articles, where you will have access to many videos, recorded videos, step by step, that walk you through the process step by step, 1, 2, 3, 4, on how to learn the software and how to make the best use out of it. So I can share these links with you later on. But definitely, if you check the Autodesk Knowledge Network, you search for structural bridge design, you're gonna find that page and all of these videos available for your consumption. Okay, we're done with the structural bridge design. We've verified that the design is sound. What about checking the excavations required for these bridges, and specifically for the piles or the foundations or the pile caps? We can definitely make use of Infraworks as well as Civil 3D. In Infraworks, we can leverage the land areas capabilities. And here it's basically by just picking that land area icon and then specifying the area where we will be excavating, and using the gizmos, or by specifying a certain numerical figure, we can specify the depth at which we will excavate. Now, because land areas have additional intelligence when compared to coverages, we can basically assign certain materials and material properties to them, as you can see from the library. So I have, for example, one-to-one stability slope. I can specify the cut slope, I can specify the fill slope as well. And all of that helps me basically get a quick feel of the quantities of cut and fill by using the terrain statistics in the Infraworks capabilities. So here we select that area and we get direct feedback about the volume of cut and volume of fill if required. Very quickly, very easy to use, and we can do it for the whole area of the bridge piers or foundations at one go. Now, this is definitely easy, quick. We can assign materials, we can check option A versus option B, and then it will also allow us, because we're working in context in 3D, we can check for instances where we have maybe clashes with some water bodies like rivers, or we have clashes with some utilities. So in some cases, we might need to excavate a little bit with a higher slope on one side of the excavation and maybe like a lower slope from the other side. All of that is possible using the gizmos and the material properties which we can influence inside of Infraworks. And then we can tell, for example, the contractor, or recommend that there may be, there is a need for some sheet piling or some retaining wall in here to make the excavation safely and erect the piers later on in the construction process. Now, inside the software, we can also create some proposals and leverage proposals to show the planned way of doing the excavations. This is just for visual purposes and to make sure that we have enough spaces on site. We know how the vehicles will move in and out to excavate, where they're gonna, for example, dump the material, stockpiles, etc., etc. So we can use the library, the Infraworks library, for the 3D equipment like the excavators, the graders, and the trucks to do all of that in 3D, and definitely use the land areas, as I mentioned, to create those tunnels or those places where the excavation will be made and the stockpiles will be stored. Now, this is for quick way, is like a quick way of getting the cut and fill quantities from Infraworks. If I want to go one step further into more accurate quantities, we can definitely leverage Autodesk Civil 3D. As you already know, there's a bidirectional link between the two. We can open the Infraworks model directly inside of Civil 3D, and this is what we're doing in that video. You can import whatever data sources you would like. You can import few or all of them, depending on the need for design. And as you can see inside of Civil 3D using the object viewer, we'll see that we have not only the terrain, but also we have the full bridge with all of its components populated inside of my Civil 3D platform. So there is no loss of data between Infraworks and Civil 3D. Now, once we are in Civil 3D, we can basically use basic functionality like manipulation inside of Civil. And here we're going to use feature lines. So just in a second, you will see that we will pick a certain view. We'll go into feature lines and we will create a feature line for the sides of the excavation, the boundary of the excavation. So feature lines are just basically like 3D polylines, but with additional parameters, which make them a lot easier to manipulate and way more beneficial to us as civil engineers. So we're creating that feature line for the outer boundary of the excavation. And then we can modify or extend these lines to have more space for the excavation on each and every side as need be. So as we decided, maybe from the side of the river, we need to have higher slope, meaning less space, but from the other sides, we can have a bigger space on the other two sides. It's all up to us as designers. Now, what we can do, we can have a more detailed, accurate representation of the volumes than in Infraworks, because we're creating some transitions, some grading, and all of that is resulting in a 3D representation that exactly mimics what's going to happen on site. Now, inside of Civil 3D, we can leverage the volumes dashboard to quickly understand the difference in volume between two surfaces, any two surfaces in Civil. And this is where we're going to get whether we have a cut situation or a fill situation. As you can see, the volume is populated, and we know that it's already a cut situation. We can also create different levels or different stages of excavating that for that foundation, whether it's based on the construction that will happen on site, certain construction requirements, or else if we have certain geological layers that we might have created using the geotechnical module, which basically runs on top of Civil 3D. So it's up to us as designers to decide how to split or slice this excavation and to what level of detail. We're done with the excavations in Infraworks and Civil. What about doing some reinforcement and documenting our bridge design further? So the way to do it, first we need to bring the surface, terrain surface, the accurate one, the latest modified one from Civil 3D into Revit. And this is where we use the BIM 360 platform. So we publish that surface into BIM 360 docs, and then we're able to download that surface or link it into our Revit environment to have the existing condition. Definitely need to have the desktop connector installed for this functionality to work properly. So once done, you will see later on that we have the surface already populated in my BIM 360 platform in docs where I can view it, I can do sections, I can place markers, etc., and then I can import it very quickly into my Revit environment. Once I get that into my Revit environment, the second step is basically by sending that Revit model, the sound, the verified, analyzed model into Revit environment. By a single click, as we've seen here, send to Revit, specifying the template, we get that model populated in Revit in 3D with all of its components showing in Revit environment. So we can either create a new model, or else we can basically update an existing one. So maybe we need to change some parameters in Revit. In Infraworks, they will directly populate inside of once we change something in Infraworks, we'll directly populate inside of Revit. Now, if we have one or more bridges in our design in Infraworks, we need to basically right-click on each and every bridge and send it into Revit. So we can't basically pick all bridges at once and send them all together. No, we need to pick them one by one and send each one of them to the Revit environment. Okay, this is just an example of showing you that even if we update anything or we change or modify any of the components in our Infraworks design, maybe we got a change for a certain requirement, or we have a certain challenging condition on site, we need maybe to change the location of a certain pier or elevate the profile for any reason. These updates, these modifications in Infraworks will be directly shown in my Revit platform, because again, these two platforms are linked together, like we have with Civil 3D. So we'll change a couple of parameters, and then automatically I send the Revit to Revit. Here I say just update existing. I can, as a designer, put the notes or put the reasons why we had to make this update. Once I hit the update button, you will see in a second that the Revit environment will notify me as a detailed bridge designer that something has changed. So now we are in the Revit platform. As you can see, we got the notification, the time of the change, who changed what. We can apply or we can ignore that change. If I apply, you will see that the model will update automatically. And the cool thing about Revit, because we have dynamic labels, everything will update in real time. So instead of going back in AutoCAD and changing all of the labels, all of the cross-section documentation, no. Once we have created those construction documents or labels, everything will update automatically, saving a lot of time and resources and avoiding many of the mistakes in the process. Okay, construction documentation, easy. So inside of Revit, we can basically create cross-sections. We can check or zoom into individual components like the piers, the foundations. We can show different iterations of them with certain rotations. We can basically create categories or groups and filter them out based on the category, etc., etc. So same like we do with Civil 3D for roads and highways, we can do the same thing for structural components coming from Infraworks like bridges or tunnels, as you see in that video. Now, the good thing about Revit, we can basically group those, and it's actually a recommended practice. We group those into different groups, and then we can give them different labels, different colors for better visualization. This is just an example of using the Revit standard functionalities for rebars in order to add free rebars, or just use maybe the classic functionality to have the reinforcement for each and every bridge component. We can add those for the abutments, for the piers, for the foundations, and even for the piles themselves. We have a standard library of components, and all of these will show up in 3D and will basically update the labels and the quantities as well towards the end of the process. So finally, we get all of these construction documentation. We have different colorings, we have different views, and definitely we have the rebar schedule, which we can split based on the bridge component. So maybe we have a rebar schedule for piers, another one for foundations, piles, etc., etc., as need be. Now, since we're talking about bridges, the tunnel design process between Infraworks and in Revit using Inventor works basically the same. So inside of Infraworks, we can create or generate a tunnel. We have a road here. We generate a tunnel from a certain station to another station, like we've done with bridges. And once we select all that, depending on a certain tunnel cross-section, we will have that tunnel generated in 3D. Now, the good thing about that tunnel is that we can also send it to Revit, and it's also parametric, gives us direct feedback about the required concrete, and we can change any of the parameters in here to change the 3D model in the Infraworks platform. Then we can send it to Revit directly for detailing, for construction documentation, and definitely for the quantities and adding all of the labels. As you can see here, we've added all the required reinforcement. We're generating the plans, profiles, or cross-section documents for construction. Same like we did for bridges is applicable to tunnels. Very quickly, Autodesk Navisworks. Since we talked about designing, preliminary design, customizing an Inventor, detailing the design in Revit, generating the quantities and the construction documentation, what about having some capability to review the design, check if there are any clashes, and do some basic 4D, 5D simulation? For that, we use Navisworks. We can push that model, whether it's coming from Revit, from Infraworks, or Civil 3D into Navisworks. And if we are in a design office, we can use that using some smartboards to have proper, efficient review meetings where all of the designers can check the models together, resolve any clashes or any problems in real time, instead of sending emails or screenshots. The other way of doing it basically is doing it by publishing the model to BIM 360 and using the BIM 360 platform in the cloud. The other use of Navisworks is basically for checking or generating the clash report. So using the clash detective module within Infraworks, we have the augmented model. We can check for any clashes between any infrastructure object. Could be between pipelines and the structural components of the bridge, or anything you can think of. We can also check for interferences. So maybe we need to have a certain clearance between two objects. That's like 30 centimeters or 50 centimeters. We can also maintain that all of these are satisfied within our model. And we can leverage the switchback functionality to go back into, for example, Revit or Civil 3D to modify or change that clash to a satisfactory condition, and then update the model inside of Navisworks. One of the major uses is basically to check for clashing between the rebars or the structural reinforcement of the bridge and other components or pipes or utilities throughout that bridge. That's also one of the major uses inside of Navisworks. The final one would be to generate what we call 4D or 5D sequencing, meaning we connect or we link the schedule of the project with the BIM model coming from Revit or Civil 3D inside Navisworks using the Navisworks timeliner. So whether it's the schedule is coming from Primavera or Microsoft Office project, or it's simply done in a CSV or Excel file, we can do all that very quickly. So we link those tasks with their durations, with their resources, probably cost as well. And then we have a 5D representation, meaning I can see the model being built throughout time in 3D in front of me with some of the notifications. I also can see a direct feedback about the total spend of the project. So if I move a little bit forward, you can see, for example, that we have certain activities taking place. Anything that's basically in red is a work in progress. Everything that's in different color is basically completed on site. And I can basically tell whether if I'm behind schedule or I'm exactly on schedule, because I can compare the baseline compared to whatever is already constructed on site. Now I want to talk about the bridge design, visualization, and communication. It's very important for us as designers to communicate the design. So inside of Infraworks, I can create snapshots that are very, very high resolution. And as you can see here, I was creating one that is basically 8K. I can go up to 9, 10K, whatever I like, and I can save these as JPEG images for sharing. And the snapshots that are created are similar to these. Basically, we have so many visual settings inside Infraworks where we can increase the level of graphics fidelity. We can add some shadow as well, and clouds and other things like that. The other way of communicating the design is basically by generating an animation using the storyboard creator. It's a few clicks that basically grants us a wonderful experience of how the model will look like as if we're driving through that model in real time. And these can be basically shown in the Infraworks platform itself or exported as a video that can be shared with anybody anywhere. We have a couple of video formats. You can change the frame, how many frames per second, and definitely the resolution of that video that you would like to share with your stakeholders. The other thing that I would like to share that Infraworks models, because they are properly georeferenced, they are to scale, they can basically mimic exactly the existing conditions or once the project is completed on site. As you can see from the pictures on the screen, the resemblance between the real bridges constructed versus the Infraworks model that was created initially. One of the major success stories that I always talk about in my webinars or presentations is this bridge design in the city of Fet in Norway. So the designers, Multiconsult, created 17 road alternatives and 8 different design bridges in Revit, and they augmented them in one single Infraworks model in different proposals. They've shown this to the public, and they've created animations, as you can see from that same model, to first get approvals, and second, basically move that into the detailed design once approved. One step further would be by using 3ds Max Interactive. This is from my earlier webinar, which I did 2 years ago. We can push basically the Infraworks model into the 3ds Max Interactive and create a gaming experience. So now we can allow our customers or the client to basically drive in a car and go around that model, whether it's a bridge, a tunnel, or a road, and experience how would that look like in real life. We can push it even into VR using HTC Vive or Oculus Rift by using some of the existing templates inside of 3ds Max Interactive. So this is about the visualization. I'm almost done with my webinar. I would like to highlight that most of these solutions that I touched upon today are already available in the AEC Collection. AEC Collection is a full package of all required design tools, basically including Infraworks, Revit, and AutoCAD Civil 3D, and definitely Navisworks Manage, which we used for the collaboration or design coordination, clash detection, and 4D, 5D sequencing. Also, we do have access, if you subscribe to this AEC Collection, to the 3ds Max Interactive and 3ds Max and the 3ds Max Interactive as well, along with all of the AutoCAD flavors if you still are working with, if you're still having some projects in 2D CAD workflows. And by the way, subscribing to the AEC Collection is actually more cost efficient than subscribing to any of the two tools available within it. So if you need to have an AutoCAD and the Revit, it's basically cheaper for you to go for the AEC Collection. If you want to have AutoCAD, Civil 3D, and Navisworks, it's cheaper to get the AEC Collection rather than subscribing to Infraworks and AutoCAD Civil 3D separately. These are some of the useful links. I would like to highlight this one, Autodesk Civil Engineering Community. So if you type http://community.autodesk.com, you will get to this page where you will have all of the latest news, latest updates, workflows, success stories, tips and clicks about the Autodesk software for infrastructure projects. I highly recommend that you check that out. The other thing that I would like to recommend is basically going to the Autodesk University website. So from Autodesk University 2018, there were so many interesting sessions about bridge design. I would like to highlight the one that was done by my colleagues Stéphane Balmain and Vincent Fredon from France. It's called the New Workflow for Bridge Design and Infraworks, Inventor and Civil 3D. Actually, I used most of their material, and I owe them a lot of material that I used in my webinar today. The other one that I highly recommend to check is Connected Bridge Design. And that session was basically delivered by Ara Ashikian, also another colleague of mine, detailing how we can use Civil 3D, Dynamo, and Revit, and even with some Python scripting to automate the process of designing highly complicated bridges like arc bridges, for instance, or pre-stressed tendon bridge. This is basically the end of my webinar. I would like to inform you that you will be getting a survey that will take you just like 5 to 10 seconds to complete. We highly appreciate if you can complete that. And now I'm going to open the floor for questions. Feel free to type in any questions you have in the chat box from this GoToMeeting webinar. In the meantime, until I get your questions, you can basically send me any of your technical queries on my email address that you see on the screen, muhammad.abuasali@autodesk.com. As I mentioned earlier, feel free to connect with me over LinkedIn and subscribe to my YouTube channel. All what you need to do, just type in my name in YouTube and my YouTube channel will show up at the very top. Okay, so we started to have a couple of questions. Let's see. Okay, how to make custom bridge templates. Okay, so from within Infraworks, if you right click, there is an option to basically create a bridge template, which you can then use in your upcoming designs. If you like, Abdullah Jamil, okay. I have the email address of each and every person who's posting the question. So I'm gonna put remarks and I'm gonna send you a link that basically helps you create those in detail. So Abdullah, I'm going to send you the link for the templates. Okay. The second question, Bashiru, okay. Instead of pre-tension or post-tension beams, can we also do, let me see if I can see all your questions. Can we also do for, I can't see the whole question. It's big. Okay. Can we also do for reinforced beams? Now, natively inside of Infraworks, we cannot generate the reinforcement for those beams or the girders. Now, you can add them maybe as additional components or include them in Inventor as part of the whole component, but that would be actually a tedious workflow because once you move those into Revit, these will come as direct shapes at the time being. So they're not completely like Revit families with all of their intelligence. So I highly recommend just use the ones available right now in the software and then create all of the rebars and the reinforcement inside of Revit itself. Okay. Please confirm the versions. Okay. Please confirm the versions and extensions required for each of the software for this workflow. I assume all 2019. Yes, it's highly recommended that you have the latest Inventor 2019, Infraworks 2019, and Revit 2019. Definitely for Infraworks and Revit or Infraworks and Civil 3D to work perfectly, you need to have the same release, the same yearly release. So if you have 2019, you have to have 2019 of Revit and Civil 3D as well. Okay. How does this workflow work with vertical and horizontal alignments, curves? Is this where Dynamo comes in? Okay. Dynamo works perfectly with the detailed design tools like Revit, Civil 3D. It also works with AutoCAD. Currently, the Infraworks API is not open for development, and hence we cannot reach Infraworks objects from Dynamo to automate certain design processes. You can basically modify the horizontal alignment and vertical alignment inside of Infraworks like I've shown you earlier. So you can basically use the gizmos, the PVIs to change the profile or the profile viewer, or select those gizmos and move the curvature or the alignment as you like within the Infraworks platform. But you cannot automate the process inside Dynamo yet. Is there an online library for Infraworks components like Revit? I'm not quite sure, at least from Autodesk, because whatever we have as components coming from Autodesk, these are the standard components, are available in the style palette or the Infraworks library itself. There might be some people or designers out there that have created custom components and they've posted them online for you to download. But if that is not the case, you can still do them inside of Inventor, import them into Infraworks, and then use them in all of your projects. And by the way, that's not a tedious process, because once you create one single component like a certain girder, inside of Infraworks, you can change the width, the height, the rotation of that component. It's not like you have to create a component for each and every girder or each and every pier. Once you have the general shape, you're able to modify that using the parameters, the parametric figures or parameters for that component. After finishing with Infraworks, do we transfer to Revit for detail? Yes, definitely. So once we're done from Infraworks, the preliminary or conceptual design for the bridge, we check and we satisfy the structural requirements, at least at a low level, in terms of having the bending moments and the shear, etc. We generate the report. We're happy with that. Yes, we right-click, we select the bridge, we right-click on it, and send it to Revit for detailed design. Where to learn Revit structure, please? Okay, I have to check for you on that. I'm not a Revit expert, but there are many ways to learn Revit or any basically software from Autodesk. We have our authorized training centers spread out all of the countries, almost all the countries in the world. We have also so many YouTube channels. So let me just show you very quickly that if you go to okay, so if you go here, YouTube, you can type in, for example, Autodesk Building Solutions, and then you will have thousands of videos about how to learn or how to augment those solutions in your workflows. We have the same thing for infrastructure. So if you type Autodesk Infrastructure Solutions, you will have a similar, okay, Autodesk Infrastructure Solutions, Autodesk Infrastructure, sorry. You will have Autodesk Infrastructure and you have the same thing over there. What also I recommend is basically going into Autodesk Design Academy. So Autodesk Design Academy will provide you with a learning material for you as a student or even as an instructor to teach a software to your colleagues or other people interested in software. You can basically go to the Learn page, take a course, and all what you need to do in order to access that is basically to sign in using your Autodesk username and password. And here you can specify what type of software you're looking for. Like I want to learn about Revit. Sorry, so you put Revit in here. You check what is the level, and then you will find too many different courses for you to learn from. In this case, we have so many architectural workflows. concept to design, etc., etc. So this is another way of learning the software. But I highly recommend that you check with our authorized training partners in your country or nearby your neighborhood. What else? Okay, let's see how many questions we have. Does Infraworks support bridges in water? Yes, definitely. So we can create bridges, but in water, I'm just questioning how would the, let's go to the Infraworks here, and let me just suppose I want to create a water body. Okay, water area. So suppose I have a river. I mean, you can still get that river from the model builder, or else if you have it as a water body, and then you can, yes, still see that you can show your components in 3D within that river environment. Now, if you don't have a surface underneath, you'll not be able to anchor those piles. But yeah, this is actually a good point to mention. In Infraworks, we only have one surface that we can basically modify and update. So at any point in time, even if I look in profile, it's only one surface being updated. It's not like Civil 3D where we can have multiple surfaces. We can have the top level of the river or water body, and then we have another surface over here for the bottom of that river. No, it's not the case. We have only one surface to design, modify, and update. So it's better to use Civil 3D in that instance, move that model to Civil, use river and flood analysis module, which is also free of charge with the Civil subscription. And then you can check for scour analysis, you can check for flooding scenarios, etc., etc. Does Infraworks support, okay, can you use Infraworks without using Civil 3D to finish a Civil project? Well, this is a great question. Infraworks is very powerful, as I mentioned, for the planning of infrastructure projects, for creating the conceptual, the preliminary design, and a little bit of detailed design. But inside the Infraworks platform, we cannot generate the final quantities, and we cannot generate any construction documentation whatsoever. No cross-sections, no plans, no profiles at all. So Infraworks cannot replace Civil 3D for that purpose. Okay, any more questions? I think I've answered most of them, or all of them, yeah. Okay, so thank you for attending. Please don't forget to answer the survey, which you will receive shortly. And hopefully to see you soon with my next webinar. Okay, thank you very much.